Today's webinar is 5G and the path forward for rural carriers.
Well, good afternoon. Looks like we were having some problems with Lucy's connection. So I will go through a couple of her slides and then we'll get the webinar started. So as Lucy was saying, this is a webinar in conjunction with RCR Wireless Award Solutions and CCA, and we sure are glad you all are here this afternoon. As you know, CCA is a competitive carrier association, and it helps rural, regional, and nationwide carriers in many different forms. It looks like Lucy's joined us back again. Lucy, let me go ahead and mute and see if you can try that again.
Sorry about that. I don't know what happened. Some sort of technology glitched. So my apologies. Can you hear me okay, Mark?
Yes, I can hear you fine.
Okay, great. I'm so sorry. So we'll be on slide 3 now. CCA's priority is advocacy, and some of our members' top issues include access to spectrum, the FCC's 5G fund, communications network security, and more. This next slide lists some of our accomplishments over the years, but as the last slide indicated, we're not only about advocacy. Mark, if you'll go to the next slide, that'd be great. Part of CCA's mission also includes providing networking and educational opportunities to our members, including webinars like the one today with Award Solutions. Award Solutions is a longtime member of CCA, and we've partnered with them on a couple of key online courses, Foundations in 5G and Foundations in VoLTE, which have been really popular. We've heard from a number of people that have completed the courses and said that they've provided some invaluable information. So I really encourage you to check them out if you've not done so already. The next one begins on June 1st, and I should also mention that CCA members receive discounts. Mark Harms is here from Award Solutions, who you've obviously already met, and he can tell you a little bit more about the programs. So Mark, I will turn it over to you now. Thank you.
Fantastic. Thank you, Lucy. Glad we were able to recover from the glitch and ready to begin the session here. So as Lucy mentioned, we have 2 of these foundation courses, one in 5G and one in VoLTE, that are coming up June 1st and July 13th. I just encourage you to take advantage of these. They're online, self-paced, and you have expert sessions, expert-led sessions as well, live sessions where you can interact with them. So today, I want to focus on 5G and the path forward for rural carriers. I hope many of you know me and want to engage in the conversation. Please feel free to use the Q&A. You'll see that in Zoom there on your toolbar. And please even use it to comment. If there's something that I say that you agree with, jump in there. If there's something that is not clear, please jump in there. I really love an idea of having interaction during these webinars, even though it's challenging with a large audience and some of the tools. But please jump in, use the Q&A. Don't hesitate. If there's something specific that you're like, Mark, I really hope you're going to get to this, please put it in there. Even start doing that now. A little bit about me. My name is Mark Harms. I've been at Award Solutions for over 10 years. I love technology. I love making it simple. I tend to focus on people in business roles. You can use the QR code there to join my LinkedIn profile. I was born in Mexico, grew up in Honduras, and just absolutely love soccer. I have a software and protocols background, and I do all kinds of different technologies focusing on 5G, IoT, MEC. I won't read that list to you. Today, what we're going to do is concisely define 5G for you. I want to look at 3 usage scenarios defined by the ITU. You may or may not have seen that ITU triangle. I'd like to talk about some key features in phase 1 and phase 2. And then explain some benefits and challenges of deploying 5G in millimeter wave and in low band spectrum. We'll articulate a little bit on the recent spectrum auction results, explain how 4G can actually be faster in 5G in some unique scenarios, and describe different approaches that operators will take in deploying 5G. So I'm looking forward to that conversation and see your thinking and your feedback on these different options that we'll explore. So let's start with 5G in a nutshell, if I can. Sometimes in our industry, we feel like things are driven by the next shiny object. And I just want to highlight that really applications are driving our need to and for 5G. And so some applications require higher throughput, HD surveillance, for example, especially if you're using that HD surveillance with artificial intelligence to trigger and denote different triggers for different events and warn you of things that are happening. Fixed wireless solutions could also leverage higher throughput. than LTE could provide. In addition, we need lower latency, higher throughput, and network reliability for a couple of types of applications like AR, augmented reality, or VR, virtual reality, or MR, mixed reality. There's a lot of requirements on latency there. There can be a lot of requirements on throughput there. And then obviously for autonomous vehicles, network reliability is also an important piece or requirement for those. And then lastly, the whole IoT and connection density requirements that it has, longer battery life and lower latency. So I just want to highlight that there are applications that are driving this trend towards 5G. It's not just about the next generation of technologies. So what is 5G? At Award Solutions, we like to define terms, technology terms, in 9 words or less. We call it a define in 9. And I hope that that helps you understand what the technology term is. I hope that helps you remember that term. And then lastly, I hope that it helps you describe that term and explain that term to others. So for 5G or 5th generation, a define in 9 that is very useful, I hope, for you, is a flexible mobile networking solution that's providing services that were previously unimaginable. And some of that is exactly what I talked about before: the lower latency, the higher throughput, the reliability, the connection density, etc. When you think about 5G, the ITU put together a useful triangle on applications, and they defined kind of 3 sides of these applications when you think about how to adjust them or consider them or group them. One is called MMTC, Massive Machine Type Communications, and it's all about connection density, probably in some cases low data rates, in other cases slightly higher data rates. But really the focus there is all about the connection density piece, and that's really important there. Another one is the low latency and high reliability piece, and that enables ultra reliable and low latency, or URLLC. So I need, like autonomous vehicles, right? We need to make sure that the break now packet, if you will, arrives on time, or the move right or move left packet arrives on time and arrives reliably. We can't have that packet drop and not get there. And then lastly, capacity and data rates enable enhanced mobile broadband. And really, when you think about this, this helps you kind of consider your applications and what applications require eMBB, MMTC, or URLLC. It's not like one application requires just one of these. And it's not like these are fixed and defined in such a way that they're fixed. Instead, this is a bit fluid. So you'll see that some applications like video primarily require eMBB. Maybe smart home obviously could require eMBB if it needs that higher broadband, but it could also require some of the connection density. Obviously, something like self-driving vehicle, AR, VR, already talked about low latency and high reliability. Some IoT things would lean towards the MMTC piece. And then some IoT things, maybe a smart farming where you have a grain collector going right next to a harvester. And as the harvester moves, the grain collector needs to move as well so that the grain isn't spilt. And so maybe that requires super low latency, and that would be an important piece. Or a smart factory may need that super low latency or high reliability, either one of those. So this is a useful triangle for you to think about when you think about the applications and the 3 different types of usage scenarios that the ITU envisioned that 5G is fulfilling. Okay, I still don't see any questions in the question and answer place, so please jump in there with a question, something that you'd like me to cover, and or comment as we go along. All right, great. When you think about 3GPP 5G performance targets, these were set again by the ITU. The downlink, 20 gigabits per second. That's really an impressive number. Compare that to LTE. LTE, the target was 1 gigabit per second. Now, in the end, we can deliver more than that now with LTE Advanced and carrier aggregation, some of those features that we've talked about before. But really, this is a 20-fold increase from 1 gigabit per second to 20 gigabits per second. Notice the 20 is on the downlink. On the uplink, we have 10 gigabits per second. Latency in the RAN went from approximately 10 milliseconds in LTE to less than 1 millisecond. Again, that's a 10-fold increase. And just to be specific, I mean, that's over the radio access network. So it's not just latency end to end, that's latency over the radio access network. The further away you go from that, obviously, to get your service, the higher that latency is going to be. A couple of others, number of devices, 1 million devices per square kilometer is pretty amazing. Cell throughput was specifically defined at 10 megabits per second per square meter. And then finally, cell edge data rates at 100 megabits per second in the downlink and 50 megabits per second in the uplink at the cell edge. One way to look at this is if you take these different components here, those primarily serve eMBB. And if you take the other ones, let me use a slightly different color. This obviously is more URLLC centric, and this is a little more MMTC centric. This should be capitalized. I hope that kind of helps on those requirements. All right, I see some questions. Fantastic. How does 5G help for current school education scenario? Raju, thanks for that question. One of the ways I think it can help is eMBB, enhanced mobile broadband. So if you can have higher throughputs for education, that should really enable you to satisfy needs in the education arena for schools, obviously for high schools, et cetera, but also for VOTEC type schools, colleges, and others. So that's one way that the education sector will benefit from that. Howard's asking about edge computing. I'll talk about that in a second, Howard. Let me just make a note on that, and I will come back and address edge computing in just a second. Awesome. And then Griff, hi Griff, how many of these become a reality? Very good. So Griff, I'm going to answer that now, and then I'll answer it more fully in just a second. But if you think about this, initially the reality is going to be focused more around eMBB, and that's going to depend on your deployment. So we'll talk about that in just a minute, a little more detail. And then an anonymous attendee is saying, so these are would be considered the 3 main sectors of 5G. The ITU triangle, I would not consider them the 3 main sectors, but they're just a good way to think about the usage scenarios that the ITU had in mind, the objectives, if you will, that the ITU had in mind for 5G to fulfill. These were the type of applications, mobile broadband, massive machine type communication, and ultra reliable low latency. 3 types of groupings that they came up with. And then in order to meet those groupings, for these applications to work well, these are some of the specific performance targets that would allow that to happen. All right, I hope that answers that question. Great. Thank you guys for the questions. Please keep them coming. Release 15 of the 3GPP, which is a 3rd generation partnership project, that's been defined, that's been released, and networks are being deployed right now. And that's really phase 1 of release 15. Phase 2 of release 15 is release 16. And release 16 is being defined now in the specs. The timetable has shifted a bit. It was going to be finished in December of 2019, and now it's going to be complete in June of 2020. The term they use is frozen, so it'll be frozen in June of 2020. And just so that we're clear, even though people aren't using this terminology yet, these release numbers continue. So even though I haven't seen many people refer to phase 3, there is a release 17, and that'll just continue. Release 17 is only in the phase right now where they're trying to determine what things to focus on. So the specs haven't really made much progress yet on release 17. People are just determining, okay, what do we really want release 17 to have? What's it going to look like, and how are we going to move forward with it? Okay, let's keep going. Release 15, define new radio. I'll define this in a bit, but that's where we get the term NR. It's really flexible, and I'll talk more about this, but it still uses OFDMA, but it provides tremendous flexibility in the subcarrier spacing. It provides flexibility with our time transmission interval. It provides flexibility with our frame structure. And it provides flexibility with the carrier size. And by carrier size here, I mean the RF channel. And in LTE, the largest RF channel was 20 megahertz. In 5G, the largest carrier size or RF channel is 400 megahertz. Again, another 20-fold increase. We've talked about the low latency piece, and then I just want to highlight there are two deployment models, and I will discuss these in a bit. And the two deployment models are non-standalone, or NSA, and standalone, or SA. And fundamentally, NSA is there so that you can leverage your 4G network, core network, to manage your 5G RAN. Okay, I see several other questions in here. Fixed wireless FWA as a fourth use case. Andres, thanks for that question. I see it as part of the EMBB use case, so great. I hope that helps that. Izette, what about 3GPP release 18? Yeah, that'll come as well. This will never end. At some point, release, I don't know what, 20 will be 6G. I'm just pulling a number out of the air there. And then Norman thinks, are there tangible differences between the 5G implementation? Yes, there are. And I'll talk a little bit about that in just a minute when we talk about some of the deployment options. All right, keep using the Q&A there. Thank you very much. So that's release 15 that we addressed. How about in release 16? Notice URLLC enhancements, connection density enhancements, think MMTC. And then a little bit of vehicle to everything. Unlicensed spectrum, you may see this discussed as NRU. And then obviously there's always efficiency improvements that'll continue to happen in the space as we continue down the road. So the specs continue to refine things, add features, and make things better. So that's release 16 and some key features in release 16. Okay, 5G radio. We talked about NR, or new radio. What is it? It's a flexible OFDMA radio protocol that's used for 5G. OFDMA is the same protocol that we use in 4G LTE. So how would you compare those two? Well, it's really interesting because they're both efficient. 5G OFDMA is slightly more efficient. And I say slightly just to give you a sense. It's about 10 to 15% more efficient. So if you're looking for an efficiency gain between 4G and LTE, you're going to have about a 10 to 15% efficiency gain, with all other things being equal. That's very different than 3G to 4G. When we went from 3G to 4G, we had somewhere around maybe a 200 to 500% efficiency gain, basically moving from CDMA to OFDMA. 5G is also significantly more flexible. In that other chart, I went ahead and listed some of those. Some of the reliability pieces give us flexibility. Some of the connection density, this is important. Our signaling plane is much more flexible. What does that mean? It allows for devices like IoT devices to sleep a lot longer and therefore use less battery. Low latency. How do we achieve low latency? Well, we need a more flexible frame structure. Running out of room there, the right structure. We can also use different subcarrier spacing. To achieve low latency, and there are other flexibilities that we get with low latency. But if we want the enhanced mobile broadband, if we want those massive capacity gains, we're probably going to need to use millimeter wave. All right, will 5G core start using cloud native infrastructure? This is a question from Howard. That is the case, Howard. Yes, 5G core is defined in a virtual way. We'll talk about that in just a minute. And so ideally, you'll be using cloud native infrastructure for that. In fact, unlike most of the virtualization that's occurred in 4G, which is more VM based, virtual machine based, I see the 5G core being more container based. But you'll have to, there's a lot to dig into there that we don't have time in this webinar. What do I think about non-terrestrial network? I really don't have a good opinion on that, Izette. Sorry about that. Thanks for the question, but I think it has some benefits, but I am not too up to speed on non-terrestrial networks. Thank you. Andres, what makes it more efficient? There's some different encoding, Andres, that makes it more efficient. Polar encoding and some other encoding that makes 5G a little more efficient. Unlike when you went from 3G to 4G, and you looked at the efficiency of OFDMA versus CDMA, that was a huge efficiency gain. Here, it's some minor efficiencies here and there that provide that. So I hope that helps, Andres, your question. And Izette, sorry I'm not able to answer yours. And then Howard, I got yours answered. Great. Okay, keep them coming, folks. I love it. This is great. What are some drivers for 5G? Well, I just may need the 5G indicator, just maybe a marketing or branding thing. I may be a roaming partner and I need to meet that roaming partner's requirements. So that's an important driver for 5G. It is a natural evolution. I may just be ready to upgrade my 4G LTE network to 5G, or I may be driven by a particular use case. And I've just listed 4 out here. I have not chosen them for any particular reason. They're just the first ones that kind of popped in my head. But I might want to think about deploying fixed wireless solutions, smart factory solution, HD surveillance, telehealth. There's several other solutions. I'm trying to pick solutions that I feel like are more realistic immediately, rather than solutions that are coming along later. All right, let me clean a couple of these off. Great, I see some more questions coming. That's great. Izette, NB-IoT and Cat-M belong to 4G. Yes, they do, Izette, but some people, because of what they're trying to achieve, longer battery life, etc., will loosely associate them with 5G every once in a while. So if you're a stickler, they're not 5G. They're defined in release. I think it's 13 and 14. Release 15 is when 5G was defined. So that's why I would say technically no, but I'm okay if you start using those as part of 5G just because they're trying to achieve things that 5G was trying to achieve or is trying to achieve. All right, Evar asked what will happen to LoRa, Sigfox, Mesh, and other. They'll continue to survive, I think. I do think that the more and more we coalesce around 5G and IoT, NB-IoT and LTE-M, will continue to diminish some of what LoRa, Sigfox, and Mesh and other proprietary solutions, mainly because of the economy of scale. But we'll see. There's a lot of fluidity in that, and you see LoRa and Sigfox still doing a lot of good things. Okay. Fundamentally, we want to increase our capacity. And when you think about increasing capacity in a 5G network, you can use more spectrum, you can use that spectrum more efficiently, and you can reuse that spectrum more frequently. I'd like to submit to you that those are the 3 ways that you have to increase your capacity. So if you're going to use more spectrum, you can use additional carriers. Again, when I'm using the term carrier here, I'm talking about the RF channel. That's the technical term, an RF carrier. So I can add maybe a 10 megahertz carrier to an existing 10 megahertz carrier that I've already deployed, thus doubling my capacity. In LTE, the maximum carrier size was 20. In 5G, I mentioned that the maximum carrier size is 400 megahertz. So there are deployments today that are leveraging 100 megahertz carriers. We talked about the efficiency piece. I can do that in my bits per second per hertz per stream. And like I mentioned in 5G, roughly a 10 to 15% efficiency gain there. But in 5G with multiple antennas, I can gain a lot of different things, beam forming and what have you, that I think will be huge. All right, I see a few more questions. Griff, does flexibility in the RF network, automatic dynamic changes with decisions made by the device or core and not a human? Great question, Griff. Most of the time, most of the decisions are made by the core network or the RAN. So it's either the G node B, the E node B if you're in non-standalone initially, and or the core that are making those types of decisions dynamically, and rarely the device and rarely the human. A couple of other questions that I see here, 1024 QAM. I don't have a good opinion on that yet, Andres. I know people are talking about it. I haven't dug into that well enough to know that the details of how effective it is and what RF conditions you could use it in. I'll talk about the bands here in a minute, Juan Pablo, and then I see is that do all UEs support 100 megahertz or, yeah, I believe most of them do. I think all 5G UEs would support 100 megahertz band, 100 megahertz carrier. I'm not positive on that, but I wouldn't see why they wouldn't. Okay, reusing the spectrum more frequently is basically taking my normal cell site and chopping that up and using it multiple times. In this case, I'm using that same frequency, that same band, that same carrier. Instead of 1 time to cover that same geography, I'm using it 6 times to cover that same geography. Thus, I've increased my capacity 600%, which obviously is pretty significant. Okay, here's a question on bands that someone asked about, Juan Pablo, I think. I'm focused on North American spectrum bands. But you can see here, traditionally, these we called low bands. All of these we called mid-band, and now these we call high band. Just for clarity, you may hear people have called in the past, I'll be a little more specific, sometimes they've called this mid and these high. But now with millimeter wave and things above 24 gigahertz, the consensus nowadays is to call these the low bands, all of these really mid, and anything in millimeter wave high band. The spec has called this FR1. It's basically sub 6. I think in the spec it's somewhere in 7 point whatever gigahertz and lower. And then FR2, or 24 gigahertz and above. Now this is important because things like subcarrier spacing, there's all kinds of other things, carrier sizes. Remember we talked about those, whether you have a 20 megahertz carrier, a 100 megahertz carrier, or a 400 megahertz carrier. All of those vary, and the options are pretty complicated, and they vary based on FR. So whether they're in FR1 or FR2, different options are available to you. So that's an important consideration and something that you need to be aware of. Okay, millimeter wave, how do we define that in 9 words or less? Short length, it's literally millimeters long radio spectrum, and it roughly begins in that 24 gigahertz band and above. So here's the 4 bands that have been defined in the 3GPP specs. I think it's in 36.104. I always get it confused. I want to go to 101, but now I think it's in 104. I may have that number incorrect, maybe 105. And you can see they each have these band numbers. And then here in the US, we've auctioned off the 24 gigahertz, the 28, I'm sorry, not this one, that's an international band, the 28 gigahertz, the 39 gigahertz, and more. And I'll talk about those here in just 1 second. All right, it looks like we've got, I think I've answered most, if not all of these questions. I'm just gonna click on Answered Live. Oh, I see some more, sorry, I hadn't scrolled. All right, very good. Do I plan to discuss regulatory environments that need to be created? Unfortunately, Ashley, I don't have time to do that today. But you're right, every country is doing things differently. And at the moment, I would argue the US stacks up pretty well against other countries. Kieran asked for a recording. We will be recording this. I'll also be sending you a PDF reference guide that has some of the key slides. How does 5G solve penetration loss in millimeter wave? Is that very simple to answer that? One way is beamforming. I'll talk a little bit more about that. And then EVAR, again, what will happen to LoRa? I think I've already answered that question. All right, very good. All right, keep them coming. This is great. Let's talk about the latest happenings here in the US around these auctions. So the 24 gigahertz auction was the FCC auction 101. And just roughly, I'm not trying to show the uber details here, and I'm only choosing the top winners here, but T-Mobile really had a big showing, AT&T had a big showing, and then a few others were worth mentioning. There's several other companies that won blocks in this 24 gigahertz band here and there. These were in 100 megahertz blocks, by the way. The 28 gigahertz band, or N261, Verizon was the big winner there. T-Mobile did some things there, US Cellular, Windstream. And these, interestingly enough, were 425 megahertz blocks. I believe that's the only one of the auctions that was that big, and that was FCC auction 102. And you can check out all of those things from the FCC website. It's actually pretty useful. All right. The latest auction was auction 103, and here you can see there was 3 different bands that were auctioned off. 47 gigahertz, and Dish and T-Mobile were the big winners there. 39 gigahertz with AT&T being the big winner there, and 37 gigahertz with Verizon being the big winner there. If you want to learn more about the other winners, you can look at my LinkedIn article, where I posted a little bit about that. Let me just share that with you right here. So if you follow me on LinkedIn, you can see where I talked about the recent spectrum auction for 5G millimeter wave. And I've got a lot of the other carriers there, like Blue Ridge or Windstream or Insight or East Kentucky Network or any of these, PTCI, you can see a lot of these listed there where they focused. But just real quickly, you can see that a lot of them are in gray, which means they had the 39 gigahertz band. You do see some orange 37 gigahertz winnings and some 47 in blue. But you can check that out at your convenience on my LinkedIn post. Great. Let me just pause here, see if there's any other questions. Is there significant propagation? Andres, I don't think there's significant propagation between the 258 and 261, but clearly the higher the millimeter wave, the shorter that wave, the less it propagates. Are there any operators that have 120 megahertz in the US? Yes, Izette. As I mentioned, these, I didn't mention about these, but these were all 100 megahertz blocks. Several of these operators won more than one block. And then, as I mentioned in the previous auction, there were some blocks that were 425 megahertz wide. And so, yes, they have huge ownership. And you're right, the maximum bandwidth would be the one carrier is 400, but you can do carrier aggregation and get more than that. There's some limitations on that right now. Mid-band auctions, great question by Ralph. And Ralph, the CBRS auction is upcoming. And that auction is 105, and it starts later this summer. And that's in the 3.5 to 3.6 range. And then there's a C-band auction, a little higher in the 3.6 to 7. I'm not exactly sure on the numbers. And that one's currently, I think, still scheduled for the end of the year, but I don't know if that will be adjusted like some of these other auctions have been adjusted. All right, I hope that answers those questions. Fantastic. You guys are doing great on the questions. I really appreciate it. Please keep them coming. All right, let's continue here. The spectrum implications. I think this is really important. If you're going to deploy 5G in low band, fundamentally, you're going to have smaller carriers because the way they've been defined, especially in the US, is smaller carriers. People have 5 megahertz channels, 10 megahertz channels, but very few have 15 and 20. There are some that do, carrier sizes in that low band. The good news, though, is even though it's a smaller carrier, your coverage area is going to be quite large. Mid-band, you might get larger carriers, more likely to see 10, 15, 20 megahertz carriers or even larger in mid-band. And you get medium coverage size. High band, you're going to get huge carriers, right? This is where we talked about a 100 megahertz carrier, a 400 megahertz carrier. Notice that we talked about going from 20 to 400 or a 20-fold increase in carrier size. So the larger the carrier, the more your capacity, the higher your peak speeds. That's critical. However, your propagation is going to be significantly lower. So these are smaller carriers. The wavelength is smaller, I mean, the carrier size is larger or width is larger, but the wavelength is smaller. So it propagates less, maybe a few thousand feet instead of kilometers. Maybe 2,000 to 3,000 feet or a half a kilometer to a kilometer, while others may be multiple kilometers or miles. So a big difference. Notice also that the smaller the wavelength, the smaller the antenna size. And this brings us some other advantages. We can do 2x2 MIMO, multiple input, multiple output antennas, 4x4 MIMO. But in midband, you have the antenna sizes are small enough where you can start doing some beam forming. Now, it's not as targeted. It's not as thin, if you will. The beam isn't quite as thin. The way I like you to think about the beam forming is that you're focusing that RF energy. So therefore, it's a little more powerful, number one. Number two, you're reusing that same spectrum more frequently. So it increases your capacity, increases your peak speed. It's a very, very important benefit. And then in the high band, we can do a lot of beam forming. And like I said, in LTE, it's more flexible. Sorry, in 5G, it's more flexible, and therefore you can do a whole lot more with that. Howard's asking about the L-band spectrum. Howard, I'm not sure about that. I don't know if that's I don't think that's the C-band spectrum. I'm not up to speed on the L-band spectrum and when that auction is coming. Thanks for your question. What's the motivation in low band by Izette? Izette, it's really all about coverage. Yes, I can do MMTC. I do get less EMBB at low band or less capacity, if you will. I think I've answered most of these other ones. Are EMBB applications possible with midband? Absolutely. If I want to use midband, maybe I have a 20 megahertz carrier there, while in the low band, I only had a 5 or a 10. So absolutely, I can leverage midband for EMBB. And with carrier aggregation, I can aggregate maybe 2 or 3 20 megahertz carriers. All right, super. Oh, good. Thanks, Howard. Yeah, it's the Legato Networks. Yeah, Legato. Yeah. Okay, super. Yeah, I'm not up to speed on that. So sorry, I can't provide more insight onto that. And is that, yes, 5G does use passive antennas like in 4G. 2x2 MIMO, 4x4 MIMO. I don't believe anyone's deployed 8x8 MIMO, although it is defined. All right, awesome. Thanks for the questions. Please keep them coming. 5G network, it's really important to think about. Here's your network set up today. You've got your 4G core. You've got your enhanced Node B or eNode B for your RAN, your radio access network. How can you add 5G? The good news is with a non-standalone solution, you upgrade your core. You can add in a few 5G G-Node Bs. You can connect them over this X2 interface with the eNode B. And now you can deploy devices that are 5G that are connected to both LTE and 5G RAN at the same time. It's a very important piece. Let me just make a couple of nuances here. Number one, all of the signaling always occurs over the LTE connection. So that's where all the signaling is going. But the actual traffic can run over LTE or over 5G or both at the same time. So that is the what's called non-standalone setup, where I basically leverage my 4G core to manage my 5G radio access network as well. So dual connectivity, all the devices are connected to both LTE and 5G at the same time, obviously where I have 5G coverage. And the master node is always the eNode B. It will always do all the signaling. And the secondary node is the G-Node B. And I do have to upgrade the 4G EPC, or my core here, my 4G core. I do have to upgrade it to handle the fact that I'm now supporting 5G devices. So we've defined non-standalone as a 5G architecture with the 4G core. Sorry, let me go back to my pen. Where the 4G core is actually supporting the 5G RAN. All right, there's another option, and that option is called standalone, or SA. And in standalone option, same functions in the 5G core now as we've deployed the 5G core. It has the same functions as the 4G core. It's fully virtualized. There's a couple of other pieces there, but another one is that the user plane and the control plane are fully separated in the core network. That's an important piece. But standalone is basically supporting your 5G RAN with a brand new 5G core. Now, let me define that again, 5G architecture, where the 5G core is actually managing the 5G RAN. Now, just to talk about this for just 1 second, there's a lot of, let me actually see if I can do this. Just to be clear, in non-standalone, there are several operators today that have deployed in non-standalone here in the US. For standalone, we don't have that many yet. In fact, to my knowledge, there aren't any yet. However, if I was a new operator, I would very likely consider deploying in standalone. And based on the T-Mobile and Sprint merger, or T-Mobile buying Sprint out, and now a new operator emerging in Dish, it's possible that they would launch directly with a standalone network rather than try to leverage a 4G LTE network, which they don't have yet. So we'll see how that progresses, but I just wanted to be clear on that. If I'm a operator today with an LTE network, the beauty of non-standalone is it allows me to deploy now, leveraging my 4G core with a few little upgrades. But if I'm a brand new operator, I may want to go right to a 5G core, fully virtualized, service-based architecture, leveraging network slicing, et cetera, and that would be standalone. The key takeaway I want you to have is the importance of non-standalone and how that allows people to move forward much more quickly than they would have otherwise moved forward. EZ, I really don't have lots of updates on option 4 or 7. Most of the industry has coalesced around these two options, option 2 for standalone, and then of course option 3X for non-standalone. If you want more information on that, ping me later and I can see what I can find. See another question on IoT sensors. Yeah, initially, absolutely, you would want your IoT sensor to support 4G. Many IoT solutions are fine with LTE-M and NB-IoT and don't need 5G. However, if you're looking for that lower latency or a more massive machine type connection, then you might want to consider moving to 5G for your IoT. All right, very good. I want to talk about a couple of other quick things. Virtualization. I think this is important. What is it? It's representing hardware resources logically through software. So rather than coupling my hardware and my software together, I'm going to decouple them. Therefore, it allows me to buy commodity hardware or commercial off-the-shelf hardware and put my software in there in the form of a virtual machine or in a container. And by doing this, I gain tremendous flexibility. Think about one little piece here. This same piece of hardware can now have one VM running in it 1 minute and another VM running in it the next. A VM that, or a container that is a totally different network function. While before my MME, my mobility management entity, for example, in 4G LTE, that was hardware and software coupled together, and it was going to be that way forever. So if I needed another MME, I had to buy a whole nother set of that. Now, I don't need to do that. I maybe just spin up another container. And because they're not tied to that hardware, I can reuse that hardware for multiple different VNFs, virtual network functions, whether that be in a VM architecture or a container architecture, either one. All right, and I see a good question here from Griff. Thank you, Griff. Yes. Another key point that's on virtualization, let me just get to that in a second. The 5G core, the idea is for it to be fully virtualized. All the network functions will be virtualized. It's a service-based architecture. But also what we're seeing is on the RAN side, more and more virtualization is occurring. And as Griff mentions in the Q&A, Open RAN will continue to evolve and impact these deployments. So Griff, unfortunately, we don't have time in this webinar to talk about things like the centralized unit and the distributed unit and this DU-CU split and how Open RAN will affect RF network deployments, but the impact could be huge. And that's something that is very dynamic at the moment and continues to grow. So I don't have a really good answer for you at this point, Griff, but we certainly see that it is a big deal. I won't get into any more on the CU-DU split. I'll just mention it here to help answer that question. I see another quick question from Wahab. Wahab, initially 5G would not do voice, but there is a feature called VoNR, Voice over NR, and that is a class, another class that we teach that is defined and is moving forward. Wahab also asked a question about disadvantage of using non-standalone deployment. Wahab, basically, you don't get some of the benefits of the core, like network slicing. There are other benefits that you may not get, like MEC, multi-access edge computing. There are other benefits that you may not get, or they're harder to achieve when you are not using your 4G core. I'm sorry, when you're not using the 5G core. So the idea is let's deploy with NSA because we can get them out quick and have an awesome network that's out and available to our customers now. And then over time transition to the 5G core so we get the full benefits of URLLC, network slicing, and several other features that are coming down. Izette, the question on VM and container is a bigger question. I'll have to address that later. A VM is a virtual machine. It's a little more, think about it as a little bigger monolithic piece of software. A container allows me to take my software and break it up into functions or even break up functions into sub-functions and gives me a little more flexibility. That's my very quick, short answer on VM and container, but would be glad to chat with you more later. Is the 5G radio design different for SA 5G compared to NSA 5G? Not necessarily. The biggest difference, obviously, is the signaling will now go across here. And then once you do that, there's also a lot of things on DU/CU, and actually the DU/CU, I shouldn't have mentioned that. That can occur on the other NSA. But the signaling will go to 5G core. There may be some other things that the radio design is different in the standalone that I'm not aware of. I'm not as up to speed on that. All right, great. Thanks for the questions. Keep them coming. Let me cover a couple of other charts. We mentioned, when is 4G LTE actually faster than 5G? Well, fundamentally, if you're going to compare, let's just compare to make it really clear, a standalone 5G network with a 4G LTE network. If your standalone 5G network has a smaller carrier size, let's say a 5 megahertz carrier, and your LTE network has a 20 megahertz carrier, then your LTE network is going to be faster because you're using larger carriers. If you are using the same size carrier, but in your LTE network, you're able to leverage unlicensed spectrum with a feature called LAA, License Assisted Access, then you're also going to be faster than a 5G network with the same amount of spectrum. Whether it be 5 megahertz or not is irrelevant, but if they both use the same amount of spectrum, today, your 5G network cannot leverage unlicensed spectrum. Not yet, it will soon in the next release, right? We saw that NRU, or unlicensed spectrum, is coming in release 16 or phase 2. Now, the other important piece that I mentioned before is that if you're deploying 5G, you're likely deploying them in non-standalone. And when you deploy a non-standalone, your device is going to be connected to both. And you'll see that kind of termed dual connectivity. And depending on whose perspective, it's EN, which is the EUTRAN, or the Evolved UMTS Terrestrial Radio Access Network. Say that 3 times real fast. And the N there is NR. So in other words, it's trying to tell you that the device can support both the 4G eNode B and the 5G GNode B. Another way you'll see it as MRDC, or multi-RAT DC. I like to think about ENDC from the device perspective and MRDC from the network perspective. That's just one way for me to think about it that makes it a little simpler for me to distinguish. So having said that, if you're in an NSA deployment and you have both 5G and 4G LTE, that's the definition of that, your device is connected to both. At the moment, though, when your device is connected to a 5G GNode B, it's not going to be able to take advantage of LAA either. So you'll see in some networks that folks will be going to 4G LTE with LAA instead of just the 5G GNode B. All right, I hope that is clear. These are some of the scenarios where 4G LTE is actually faster than 5G. Let's get into some deployment things, and then I'll give us a few minutes at the end for questions. So number one, your strategy should really identify the 5G drivers, and those should develop your strategy. So make sure that you're clear on why you're deploying 5G. What are you trying to achieve by deploying 5G, and let that dictate your strategy. Number two, you got to evaluate your assets. What spectrum assets do you have? What network upgrades are required? Think about your network assets. In some cases, you may not have your own 4G core. Well, this may give you an interesting opportunity to leverage someone else's 5G core as well. So you got to think about that. If you do have your own 4G core, or if you're using another 4G core, you're going to have to upgrade that to make sure it supports the 5G RAN. Think about what spectrum assets you have so that you know what antennas you're going to have to deploy, what radios you're going to have to buy, and how that's going to work, and how that's going to affect the propagation and the capacity that you're wanting to get to solve the strategy that you're trying to execute. I would say that you got to start deploying. I think it's important to start now. I would not wait much longer. I would start with what I have and learn from that. I would obviously learn more and more about virtualization. We already talked about the core being virtualized. The RAN is being virtualized with Open RAN or Virtual RAN. And that's just going to continue to drive things in very unique ways. And especially in the competitive carrier association world, the opportunity to share cores, to share RANs, to do all kinds of things. Virtualization just enables that tremendously. I'll give you one last example on this, and this is just the opportunity to focus resources in one area versus another if you have something like a centralized RAN or a CRAN, which begins to build upon the virtualization piece. But with folks now working from home, operators have been able to leverage CRAN to focus more of their resources on cell sites at home during the day, rather than focus all of their resources on cell sites that cover offices during the day. So just a quick piece there. Obviously, your relationship with your vendors and mobile providers is very critical here. There's a lot of options here that you need to consider with them based on your strategy. And it's a very dynamic market, and I'll talk about one of those here in just a second. And then don't forget your transport. If you're looking to EMBB, enhanced mobile broadband, then you better make sure that your transport is fiber and your transport is ready to handle the tremendous amounts of traffic that you're going to experience in 5G. I want to quickly address one hot topic, and that is dynamic spectrum sharing. Let me just go here and do that. So with dynamic spectrum sharing, let me make this a little bit bigger. There we go. With dynamic spectrum sharing, I have a carrier. I'm going to make that just a little bit bigger. And let's say this is my 10 megahertz carrier for LTE. With dynamic spectrum sharing, what I can do is leverage this exact same carrier and carve out a piece of it for 5G. And in some implementations, this is static, even though it's called dynamic spectrum sharing. And those are probably some of the implementations that you're hearing about these days. And in some, this is dynamic. In other words, as my need arises, I can make the 5G portion a little bigger, or I can make the 5G portion a little smaller. And so the whole concept here is in the same band, in the same block, I can have one RF channel. And that one RF channel I can use for 4G LTE today, and I can add in a 5G carrier in that 4G LTE carrier, thus supporting both 5G and 4G in that same band, in that same block, and making it easier for me to begin to deploy 5G. I don't have to find a new spectrum band and a new block and clear it in order to start that deployment. So lots of obvious options. The time to market benefit is key. It allows me to get that 5G icon on the UE. Be very careful on this one. There's a lot of things happening here. Make sure you're clear with your vendor, what they're doing, how they're doing it. Some cases, these are static. In some cases, it's dynamic. There's a lot of restrictions. We don't have time to get into all those details, but please make sure that you're really in detailed conversations with your vendor on that. I see a few other questions. Is that asking about fiber? I don't know that we have fiber for all our sites in the US yet, but it's very important if you're going to support 5G and the incredible peak data rates that it offers. You need fiber in many cases. What would be the gain loss of capacity in DSS in 100 milliseconds? I don't know if you mean 100 megahertz. I'm not sure I understand that question, Joe, because sorry about that. Please work with me outside of that. DSS only works with NSA. That's the intent, Andres. It enables you to deploy in an NSA network more quickly and not have to find and clear new spectrum band. And then Griff, other than turning on the 5G light on the phone, what would be the advantage of that? That's really the main thing, Griff. The other one is the coverage. So if you're already deployed LTE, let's say at 800, 850, 700, it doesn't matter, a low band spectrum, and you want that coverage for 5G, then DSS enables that. If you're planning on deploying 5G in millimeter wave, then you're only going to do that in spot areas. And so in order to get that coverage and that slight benefit of 5G across your network, DSS can enable that. I hope that answered that question, Griff. All right, very good. One possible path forward, upgrade your 4G LTE core, obviously, so it can support the 5G radios. Deploy targeted 5G radios. Consider your spectrum options, low, mid, or high. And that's going to depend and drive you towards DSS or away from DSS. Maybe you don't need DSS. Maybe you have a 5 megahertz low and another 5 megahertz in another low band, and you're going to use that for 5G. And then if you have millimeter wave and you're really trying to achieve a enhanced mobile broadband type of solution so that you can do HD surveillance or fixed wireless or some telehealth solution, then you can do that. So those are some of the one possible path forward for competitive carriers. We've covered a lot of ground today. I hope this has been super useful. Thank you. Thank you so much for participating. Thank you for jumping in with questions here. I hope I've been able to answer those questions, and those have been on the spot. If you'd like to connect with me, you can do that. Just open up your camera on your phone. You can join my LinkedIn network over here, or you can join our class that we mentioned at the beginning, Foundations in 5G. That starts in June 1st. The Foundations in VoLTE starts in July. All right, I'm going to pause there and see if we have any new questions, or if anyone has any other things that they'd like me to discuss. So actually, I'm going to leave that up so you can use those 2 QR codes. I see a question regarding MIMO. Yeah, Andres, there's a lot of challenges around MIMO. There's a lot of benefits around it as well. And I do think over time, we're going to see more and more massive deployment of massive MIMO. Yes. That's my very simple answer to your very in-depth question, Andres. I know that's not doing your question justice, but just wanted you to know that. Can we use DSS in SA mode from Izet? I mean, I think we can. I'm not sure on that, but you got to think about what you're trying to achieve. The whole idea with DSS is I have this 4G LTE carrier already, and I don't necessarily have a new band for 5G. So I'd rather use that band for 5G and continue to use it for 4G LTE. That screams NSA. But technically, I don't know if you can then move into SA and still do that and separate the two. I don't have the details on that. Thanks, Bruce. Glad that you were able to make the webinar. I'll hang out here for a couple of more minutes, see if any more questions jump in here. Rolf, if you have choices, would you start deploying in C-band or millimeter wave? That's a good question, Ralph. And you know, the C-band, obviously maybe you already have some of that. I can't think of the word right now, incumbent user on C-band. I think it depends on what you're trying to achieve. So let me give you some examples. Let's say I'm a competitive carrier and I'm in a town that has a community college, and I want to do something in that community college to support them with a enhanced mobile broadband solution, some high data rate, maybe some lower latency for some things. Well, maybe if I had millimeter wave, I would like to leverage that because I have a much higher opportunity for those peak data rates and higher capacity. So that may cause me to lean towards that because that's a relatively well-defined geographic location that I'm trying to cover. And a couple of small cells may do the trick. I may even be able to partner with them and deploy some of that internally or whatever. If on the other hand, I'm trying to cover a larger area, maybe a very big area for fixed wireless, well, that may drive me towards C-band. If this neighborhood has 10-acre lots and it goes on for miles, then I may want to do a C-band deployment there. If the neighborhood has 1-acre lots and it goes on for 5 to 10,000 feet, then I may want to use millimeter wave. Again, I get that higher capacity, but not that coverage. So it really depends on the use case that's driving you, Ralph, on what you want to deploy there. I think I may have skipped over some other questions there. Izette, glad that you liked it. Is there any known active DAS that supports 5G currently? Juan Pablo, I'm not sure. I would think so, but I'm not 100% positive on that. Harold, when do you expect 4G to sunset? Man, I think it's going to be a while. I think it could be 5, 10 years. I think we're going to see both of these for quite a while. So we'll see. I mean, in many cases, the CDMA network is just now sunsetting. So I think it's going to be a long time. Can we do some type of beamforming with 4x4? Anton, not that I'm aware of. In mid-band, you've got roughly the capability of doing 64 antennas. I'm using that 2.5 and 2.6 gigahertz band as an example. You could do 64 antennas, and there is where I've heard of some lower or higher granular, well, I'm saying that word, bigger beams. Let's just make it simple. but I haven't heard much beneath that, less than 64 antennas. But I may not have the latest on that. But just my insight is no, I would think you would want 64 antennas. Maybe you could get away with 32 antennas and do some very wide beams. I'm not sure. When do you expect more affordable 5G mid-tier and low-end solutions to become available in the market? Again, great marketing, market type question that I may not have the best insight in. All right, I see that I am 1 minute over. I've got another minute or two. If there's another question that comes in, I'd be glad to answer that. Or if Ben or Lucy or Bev have any final comments that they would like to make, you guys are free to make that as well. So thank you again. I really do thank you for your participation. I hope this was super useful for you. Thank you all for joining. It was really great. I love all the questions. I really love an interactive session, and I hope you found it useful. By the way, we will make this presentation available. The recording will be available. We'll have a PDF reference guide that has some of the key slides in there. And if there's something else that you have, another question, feel free to follow up with me. You see my email address here, connect with me on LinkedIn, etc. But I really want to thank you. I really want to thank CCA for this opportunity and RCR Wireless for hosting it. We love partnering with CCA, and we love this opportunity to share some information on 5G and talk about potential paths forward for many of our CCA members. I hope this was helpful, and I hope to see you next time. You're free to drop here. I'm going to just spend 1 or 2 more minutes on questions. I see a few more. Tom, I'm sorry that you couldn't get the QR code to work. No problem. Send me a LinkedIn invitation. I'll try not to deny it. I'm just teasing. Of course, I'll accept it. Passive base station antennas with many operators moving towards active antennas. I'm not sure. Anonymous attendee, I'm really not sure. I see a couple of thank yous. Awesome. Thank you, guys. All right. I think we'll call it a wrap. Thank you all so much. I really appreciate it. Have a wonderful afternoon. Be safe, stay healthy, and I'll see you next time. Bye-bye now.